if an interstellar object whirling through our solar system is
a development that has fundamentally and dramatically altered the class
known as 3I divided by Atlas, could challenge everything we...
tracking stations across the globe detected the split. Atlas.
Interstellar comet C/2025 K1, known as Atlas, has been attracting the attention of the scientific community and astronomy enthusiasts since mid-2025. Unlike typical comets that are born in our solar system, this comet originated in interstellar space, making it the third confirmed interstellar object to visit our solar system after 1I/Oumuamua in 2017 and 2I/Borisov. Its discovery and subsequent observations are changing the way astronomers think about the composition and behavior of comets beyond our solar system. Comet Atlas was first detected as C/2025 K1 by the Asteroid Terrestrial Impact Last Alert System, ATLAS, a network of wide-field telescopes designed to detect small objects with a potential impact with Earth. The Atlas station in Chile first detected the object on July 1st and 2nd, 2025, 10 and 11 Tyr 1404, and subsequent observations quickly showed that its orbit was hyperbolic, a clear indication that it was not within the Sun's gravitational field and came from interstellar space, hence the name Third Interstellar/Atlas, 3I/Atlas. Rapid data sharing between observatories around the world allowed orbital surveys and physical follow-up to begin within days. A comet is a space object made of dust, frozen gas, rock, and organic matter. As it approaches the Sun, its ice evaporates, creating a beautiful, bright tail in the opposite direction of the Sun's rays. This tail and central nucleus are the main features of comets. But most comets orbit the Sun in elliptical orbits, which keep them within the solar system. In contrast, interstellar objects come from other star systems and travel along hyperbolic paths. In this way, they provide valuable natural samples of materials and conditions elsewhere in the galaxy. But it should be noted that these objects have never been proven to be alien spacecraft traveling to us from the depths of the universe, and the controversy surrounding them remains purely hypothetical and even pseudoscience. They can be considered small objects that carry within the chemical and physical history of other planetary systems. In fact, any interstellar visitor offers a unique opportunity to test models of planet formation, the chemistry of exoplanets, and the distribution of organic matter throughout the Milky Way. One of the researchers' efforts has been to examine the characteristics of Comet Atlas to gain a complete view of it as the third confirmed interstellar object. Estimates of the size of the nucleus of Comet Atlas vary. Initial studies suggested that the nucleus was from a few hundred meters to several kilometers in diameter, depending on assumptions about reflectance albedo and dust production. Regarding the composition of the constituent materials, spectroscopic measurements indicate a rich chemical composition. In particular, the high ratio of carbonaceous volatiles, such as carbon dioxide, to water is striking compared to many comets in the solar system. This chemical fingerprint points to different formation environments or thermal histories in the comet's parent system, and is a form of direct evidence that astronomers use to refine theories about how solids and ices form and evolve around other stars. One of the most exciting findings about Comet Atlas came from ultraviolet and X-ray observations that showed that, while it was still far from the Sun, the object was expelling unexpectedly large amounts of water vapor, stretching out to about 2.9 astronomical units. Instruments including NASA's Swift Observatory measured the rate of water loss at tens of kilograms per second, a rate that researchers liken to a fire hose and is unusual for comets in the solar system at that distance. The observations raise new questions about how ices form on interstellar comets, and have scientists wondering whether comets that form around other stars might behave very differently from the comets we know. Comet Atlas has been observed by a wide range of instruments, including ground-based telescopes including Gemini and other large observatories. Space telescopes like Hubble, Mars orbiters that were well-oriented during the comet's passage, and of course, amateur telescopes. Hubble's images showed a teardrop-shaped halo of dust emanating from a compact nucleus, while Mars orbiters captured more detailed views as the comet passed close to the red planet, helping scientists monitor the comet's activity at different distances and angles. The European Space Agency's ExoMars and Mars Express orbiters also pointed at the comet as it approached Mars, quickly exploring this interplanetary asset. Comet Atlas's position in the sky is not expected to be a sight to the naked eye. Based on the comet's brightness and geometry, it will remain faint and will require astronomical instruments, especially a telescope, to observe. As a guide to where to look, websites such as TheSkyLive and other similar astronomical tools provide up-to-date positions, magnitude predictions, and sunrise and sunset times for observers using telescopes and binoculars. The comet is expected to make its closest approach to Earth in 2025, on November 25, 2025 for Azar 1404, at a distance of approximately 0.403 astronomical units, about 60 million kilometers. A distance that is still far for night sky observers and therefore expected to be invisible to the naked eye even then, requiring at least moderate amateur telescopes to observe. For best observations, observing sessions should be planned around sunrise or sunset when the comet's angular distance from the Sun is at its best. Each interstellar comet raises more questions than it answers. For example, how representative is the composition of Atlas of other star systems, and did it form in a region very different from our own Kuiper Belt or Oort cloud? Continuous monitoring of its motion and laboratory analysis, modeling, and comparison with similar objects will provide a better classification of Atlas's position. Comet Atlas is also a rare interstellar messenger that has surprised astronomers by displaying volatile behavior and distinctive chemical characteristics, and has also attracted the attention of amateur astronomers and astrophotographers who are eager to point their instruments to the sky and not miss the opportunity to meet this guest from interstellar space. Although this comet will not be visible to the naked eye, the collaboration to discover, characterize its behavior, and image it demonstrates the power of collaborative international scientific efforts, especially when a guest from beyond the solar system approaches our home. It remains to be seen how well we can understand its message.